Welcome to my YouTube channel Modi Mechanical Engineering Tutorials. So in this video I would like to explaining about some of the MCQ questions onto the metal cutting processes. So this is my part 6 MCQ on metal cutting. So let us start with the question number 1. So before starting the question number 1, subscribe to our channel for similar kind of videos. And also in this channel you should find some of the fundamental concept about mechanical engineering. So now we will start with the number 1 question. Segmental chips are formed during machining. So basically this question is related with the types of chips is being formed during the metal cutting operations. So basically that will be the 3 kind of chips is being formed. So first one, that will be the continuous chips. So basically continuous chips is being formed into ductile kind of materials. And the second one, that will be the discontinuous chips, or you can say segmental kind of chips is being formed. So during the machining of hard materials, or you can say brittle materials, the segmental chips are formed. And continuous with the built up edge kind of chips, when the frictional resistance between two top face of the tool and the chips is being higher, so that will be micro wheels is possible, and due to that micro wheels it will be form a built up chips, or you can say continuous with built up edge. So here the segmental chips, or you can say the discontinuous chips, are formed during the which kind of materials? So option number 1, mild steel. So mild steel, it will be the soft kind of materials, or you can say that will be forms the continuous chips. Second, cast iron. So cast iron is a category of brittle materials, so that will be the possibilities. Then high speed steel, so steel having a good ductility, and high carbon steel. So option number A, that will be the category of steel. B, that will be the category of cast iron. C and D, that will be also category of steel. So only one option, and that will be cast iron, that will be in the category of brittle materials. So brittle materials form segmental kind of chips. So the answer number B. The next question. Which angle on tools is provided to control of chip flows? So basically this question is related with the geometry of single point cutting tools. So the options: A, clearance angle, B, relief angle, C, lip angle, and D, side rack angle. So let us see with the tool geometry. So starting with the tool geometry, so first option, that will be the clearance angle. So just you can see this is our clearance angle onto the single point cutting tool. So basically, so the purpose of this clearance angle is to prevent the rubbing between the workpiece and the tool flank. So that will be not the controlling the chip flow. So clearance angle is not possible. Then B, and that will be relief angle. If it will be the side relief angle, or you can say and relief angle. So in case of the side relief angle, the purpose of this angle is also same as the and relief angle, or you can say clearance angle. So clearance angle, the second name is and relief angle. So A and B, that will be having a same purpose, to control the, or you can say to prevent the rubbing between workpiece and tool flank. Now I will talking about option C, and that will be lip angle. So generally purpose of the lip angle, that will be the more lip angle gives the more strength to the tool tip. So that will be also not control the chip flow. And last one, and that will be the side rack angle. So the purpose of the side rack angle, this one onto the single point cutting tool like this, if this is the one kind of surface, so this angle, it will be called a side rack angle. So side rack angles to control the chip flow. So which angle on tool is provided to control the chip flow? So the answer is D, side rack angle. The next question. Larger and cutting edge angle, which kind of effect onto the tool life? So option A, that will be increase the tool life. B, decreases the tool life. Does not affect onto the tool life, or none of the above. So this is also from the geometry of the cutting edge angle. So basically the purpose of the cutting edge angle, and that will be to avoid the rubbing between the edge of the tool and the workpiece. So if you are increasing that and cutting edge angle, so that will be also increasing the tool life. So according to its relation by increasing or decreasing, so for the larger and cutting edge angle increases a tool life. So option A, that will be increasing the tool life. Then question number 4. The angle between the shear plane and on which is called a shear angle. So in my description, the link is given to you, the derivation of shear angle 5 in case of metal cutting operations. For more detail, so you should find the link in my description. So in the case of these questions, the angle between the shear plane and work surface, tool face, normal to the tool axis or flank is called a shear angle. So basically the angle between shear plane and workpiece is called as a shear angle. So the answer A, work surface and shear plane angle, it will be making a shear angle. So next question. The factor responsible for the formation of continuous chips with built-up edge is. So the option A, low cutting speed and large rack angle. B, low cutting speed and small rack angle. C, high cutting speed and large rack angle. And option D, high cutting speed and small rack angle. So basically for formation of continuous with built-up edge kind of chips, the low cutting speed is responsible. So the option A or B, which will be containing with low cutting speed. Then after, the second important part, if you want to form a discontinuous with built-up edge kind of chips, so generally it will be fine for the small rack angles. So according to the given options, the low cutting speed and small rack angle, which is responsible for formation of continuous chips with built-up edge. So according to the given question, answer B. So the low cutting speed and small rack angle. Then next question. The binding material used in cemented carbide tool is. First one, that will be the tungsten. Second, cobalt, chromium and silicon. So basically for binding materials, most of the cases it will be cobalt is being used. So generally tungsten, it will be used at the elevated temperature and that will be having a good hardness. Basically chromium, that will be resistance of the corrosion as well as that will be improving the properties. And silicon, that will be also used for increasing the hardness. So basically as a material compositions, cobalt, it will be act as a binder materials. So in the binding of the material used in a cemented carbide tool, and that will be cobalt. Then next question. In machining of metals, the chips breaks due to which of the work materials? So basically the option A, that will be the toughness, second ductility, work hardening and elasticity. So first toughness, that will be the material properties. So that will be not the affecting parameters, or you can say properties which breaks the chips. Second one, that will be ductility. So more ductile materials, it will be having a continuous chips. So that will be no any kind of chance for this kind of chips breaks. C, work hardening process. So due to that hardening process, material becoming harder. So that hardening process, that will be tend to increasing the chip breaks. And option D, that will be elasticity. So all the elasticity kind of property is present into the materials, it never breaks the chips. So only possibility with these options, and that will be C. Work hardening chip breaks are failure. The next question. The angle on which the strength of the tool depends is first rack angle, B cutting angle, C clearance angle and D lip angle. So basically in the merchant circle diagram for force analysis, the most important part, and that will be the rack angle. So if you have a rack angle, then you should find the shear angle. So according to the strength onto the tool. So basically rack angle, it will be in contact of the vertical face and the top face of the tool. So rack angle, that will be having given strength to the tool. So the option A. The next question. The tool material for faster machining should have A, wear resistance, B, raid hardness, C, toughness and D, all of the above. So that will be the category of the required characteristics of the tool materials. So for detailed study, I already explaining in my video. You should find the link in my description, the cutting tool materials. So basically all the three, like wear resistance, raid hardness, toughness, which is required into the tool materials. So according to that, all possibility of A, B and C options, and D, that will be all of the this. So the final answer of these questions, and that will be option D, all of these are the responsible parameters for faster machining. Then next question. The cutting fluid mostly used for machining steel is the option A, soluble oil, B, water, C, dry and D, heavy oils. So basically for working onto the steel, always that will be a soluble oil as a cutting fluid that will be used for the machining of the steel. So here that will be the option A, soluble oil. So if you want to work for the detailed study, the link it will be given into my description for characteristics of the cutting fluids. So if you like this, so subscribe, like and share Modi Mechanical Engineering tutorials. Thank you very much.